Hello, welcome to the Chapter 18 questions on thermodynamics. The first couple of questions here are just going to go over some basic definitions about entropy. Then we'll start to do some calculations. So I'm really just going to talk about how I sort of think about answering these problems, and hopefully that'll help you when you're starting to sit down and work through these kind of problems as well. So the first question says we have 1 mole of each of the following. So we have the same amount of each of these compounds, so having the same amount is important. We've got a couple of different things to notice. We've got some gases, we've got some solid, and then we've got a liquid. And the goal is to arrange these in order of increasing entropy. So what we need to think about are states of matter, because one of the things about entropy is entropy or disorder increases as you move from a solid to a liquid to a gas. So that's the first thing. So that lets us know right away that zinc sulfide is going to be the lowest entropy because it is a solid. And then after that has to come the liquid. And then what we have to do is we have to be able to determine what is going to be higher entropy, C3H8 or C2H4. And the rule is the more atoms you have, the more entropy that system can have. And the reason for that is if we sort of think about atoms being able to jiggle around in space, if you have more atoms moving at the same time, they can create more disorder. So for number 1, the answer is going to be E. All right, number 2, a reaction that is spontaneous. And we've got just some choices here. So this is just going to be a definition type question. What does spontaneous mean, or how does spontaneous relate to one of these other words we're going to see in this problem? So just real quick, we'll go through all the choices. Will be very rapid as written, or if we jump all the way down to the bottom, will occur very slowly. So these are sort of the opposite kind of statements. Hopefully you know spontaneous reactions do not say anything about the speed of a reaction. Reactions can be very slow and spontaneous, so the rusting of metal is an example of a slow spontaneous reaction, or they can occur very quickly. So if you think about sort of the energy released during an explosion of a bomb, that's a spontaneous reaction that is occurring very, very quickly. All right, so A and E are definitely not the answer here. If a reaction is spontaneous in one direction, it has to be non-spontaneous in the reverse direction. And a lot of the times the way this is sort of shown is with a little ball rolling down a hill. So if my ball is rolling down the hill this way, once it gets to the bottom, it is not going to spontaneously roll back up the hill. Okay, so it can be spontaneous in one direction, but it is not going to be spontaneous in the other direction. Okay, so B is not correct. C will increase the overall entropy of the universe. That is the correct answer here. That is the definition of entropy, and sort of how entropy of the universe is always increasing in spontaneous reactions. Okay, so C is the correct answer here. Just to talk about D, spontaneous reactions will proceed from left to right as written. So in this case, if you're proceeding from left to right, you will have a lot more products than reactants. So the equilibrium would lie far to the right, not the left. So that's why D is incorrect. All right, number 3. Which of the following processes results in a decrease in entropy? So if we're talking about a decrease in entropy, we want the system to become more ordered and less disordered. Okay, so let's talk about what these are showing us. For number 3A, dissolving sodium chloride in water. So this is taking a solid and dissolving it in water. That would be an increase in entropy because you would have these ions that are forming in solution. Sublimation means going from the solid state to the gas state. If you go from a solid to a gas, we know entropy has to increase. C is going to be the correct answer here. So C says dissolve oxygen in water. Now, the reason this is the correct answer is oxygen is a gas at standard conditions. So at room temperature and 1 atmosphere of pressure, oxygen is a gas. When you pump it into water, it now becomes stuck inside that liquid water. And so when you have a gas, this oxygen is able to sort of bounce around freely in the size of the container, whatever, a room or something like that. But when you dissolve it in water, it becomes stuck in that solution. Okay, so C is going to be the correct answer because you sort of condense where your oxygen is going to be located. Just real quick, boiling alcohol. When you boil, right, you're moving from a liquid state to a gas state. So we've already said as you go from a liquid to a gas, entropy increases. And then E sort of works the same way. You are creating a lot of gas product during an explosion of nitroglycerin. So you probably know you also create sound waves, an explosion of fire. So all of those leads to an increase in entropy. So that's why C is the correct answer here. So number 4, we're going to calculate the delta S for a reaction. And we're given an equation here where diamond and oxygen are combining together to form carbon monoxide. Just to remind you, if we're calculating a delta, the way to think about that is we're going to add up all of our products and subtract from that all of the reactants. All right, so in this case, there is only one product. That's carbon monoxide. That coefficient of 2 means we really have 2 moles of carbon monoxide, and we're going to multiply that by the entropy value for carbon monoxide, which is 197.9 joules per mole Kelvin from this table. So those are my products, and I'm going to subtract from this my reactants. Okay, so there are 2 moles of carbon in the diamond form. All right, so that's 2.43 joules per mole Kelvin. And then I'm going to add to this my 1 mole of oxygen gas, which is 205.0 joules per mole Kelvin. All right, and I'm going to close that parentheses. So we can go ahead, we can do the math here. I'll give you a couple of seconds to do that. You might want to pause the video while you're typing this in on your calculator. But what you should get at the end for the delta S of the reaction is positive 185.9 joules per Kelvin. All right, now if we look at our overall reaction, notice what we're doing. We're going from the solid state for one reactant to just having things in the gas state. So because we're moving from a solid to a gas, you might expect an increase in entropy, and that is what we find here. All right, so delta S means we are increasing entropy for this reaction. So now let's go on to the second page of these reactions. All right, this is number 5, is just going to be another definition type question. It says the standard free energy of formation of blank is 0. So this, again, is just a definition. And what we have to know is that the delta G of formation, so that's going to be a subscript F, that is 0 for any element in its standard state. All right, so let's talk about what I mean by standard state. The standard state of an element is the form that you find that element at if you are at room temperature and 1 atmosphere of pressure. So we can sort of go through this list. Number 1, what's important is that we are talking about elements. Okay, so right off the bat, we can exclude water as being a choice for this because water has 2 elements in it. So now what we could do is we can sort of go down through the rest of this list. Bromine solid. Okay, so a couple of things are important here. We need to know the standard state of bromine. The standard state of bromine is a diatomic. Okay, so it is Br2, but it would be a gas in the standard state. So that's an incorrect answer here. Same thing for C, oxygen. Even though oxygen is a gas, remember oxygen is a diatomic molecule, just like bromine is. So C is incorrect because oxygen would need to be O2. Then we go down to D, nitrogen gas. Nitrogen here is a diatomic. It is in the gas state. So D would be the correct answer for this problem. E, because it contains that oxygen, would not be correct. All right, number 6 is another definition type question. This time it's going to ask us for a reaction to always be spontaneous based on values of delta H and delta S. So we need to know that there's an equation that relates delta H and delta S to delta G. That's delta G is equal to delta H minus T delta S. So in this equation, we also need to know that delta G is less than 0 for spontaneous reactions. So what we need to do is we need to somehow think about what values of delta H and delta S will always give me a number that's less than 0. So number 1, if we need to have a number that's less than 0, always the delta H should start off being less than 0. So I need to have a negative delta H at the start. Now my value of delta S, notice this is being subtracted from delta H. So if I try to make delta S negative, it would actually be interacting with this negative sign in front, this sign right here. So we don't want to make delta S negative. In fact, what we want to do is we want delta S to be positive. That way we're taking a negative number and subtracting something from it. Okay, so that means delta H needs to be negative, delta S needs to be positive. So that means D is the correct answer here for always being spontaneous. All right, if we jump down to number 7, we can sort of go through some similar kind of thinking. This time, we are given a graph of G on the y-axis and T on the x-axis. So that's really similar to our delta G equation that we just wrote. The T in our delta G equation, that is our x value. Delta G can be our y value. All right, so if we have delta G is equal to delta H minus T delta S, another way of thinking about this is having our line equation, y is equal to, now notice there's only one variable here, delta H, so we can't call that our mx. This is going to have to be our value of b, and then we have m times x being our T delta S. So I'm going to rearrange this equation a little bit just so we can see how these values correspond to either being positive or negative. So delta G will be equal to negative T delta S plus delta H. All right, and what that is a y value is equal to x times m plus b, because I know the t is on the x-axis here. All right, now t is always going to be a positive number when we're talking about Kelvin. So the negative sign here, the negative sign really goes with our delta S. So m is equal to negative delta S, or negative m is equal to delta S. All right, now if we look at this chart and this line, we should know that the slope of this line is positive. Okay, it's increasing as we move from left to right. So if the slope is positive, the negative of a positive number will be a negative number. Okay, so what that means is delta S has to be negative because our slope is positive. All right, so delta S is negative, so that means our choices have been sort of whittled down to A and B. All right, the delta H value is our y-intercept. The y-intercept is going to be right here. We can see that's a positive number. So because this is positive, for delta H, we said delta S is negative. A would be the correct answer for number 7.